This is video number 3. It's a theory video, and what I'm going to do is I'm going to show you how to use the table for these angles to find the trig ratios for other important um, angles, so other trig ratios for important angles. Okay, so for example, we're going to find it for theta equals 3/4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 25 pi over 4, and minus 13 pi over 4. There's two key ideas. The first key idea is that pi over 4 is 45 degrees, and it's 1/8 of a circle. If you can keep that in mind, then it makes life easier. And then the other key idea is going to be just the signs of x and y, in particular quadrants. We did this at the beginning of the semester. In quadrant 2, we know that x is negative over here, but y is greater than 0. In quadrant 3, x is over on this side, so that's going to be 0, and y is below the x-axis, so y is negative. And then over here, we're going to see that x is positive, but y is less than 0 in quadrant 4. So I just want to remind you of these things right here, the signs of x and y's. Okay, so let's go to it. Okay, we're going to use this table, and in the practice problems, we're going to use this table too, to figure out, to answer all this question. So here, if you notice this, these are all multiples of pi over 4, so we're going to be able to use what we know about pi over 4. And again, I'll show you what I mean by that. So remember that our trig functions are defined by going a certain angle on the unit circle. So when we go pi over 4, we got that the x and y coordinate were the same. They were both square root of 2 over 2. So that meant that the cosine of pi over 4, the x coordinate, square root of 2 over 2. And the same for the sine, since x and y are equal, because it's an isosceles triangle. And then the tangent of pi over 4 is this y side over x side. And since y and x are equal, we're going to get 1 for the tangent. So everything else we need to do is just going to be based on that. So the first angle is 3 pi over 4. So that's the angle. So again, that's going to be 3 times pi over 4. So that's going to be 3 45-degree angles. So that's the same as 135 degrees. So we're going to go, that's 45, 90, that's going to be 3 pi over 4. So that's going to be my theta equals 3 pi over 4. Oops. Again, camera's out of focus. Let me fix it. It'll come back into focus. There we go. Okay. So and notice that this is the key right here, is that this x is going to be the opposite of this y is the same. So I'm going to draw that down here because that's kind of in the way, but just to point out that this x coordinate here is going to be the same distance. So this is going to be minus square root of 2 over 2, and then the y coordinate is going to be the same. Okay, hopefully that makes sense to you geometrically. So again, I'm just drawing it down here. Here's the unit circle. We go pi over 4, that's our reference angle. And then to go 3 pi over 4, that's going to be 3 of these, so we go to here. That's theta equals 3 pi over 4. This is square root of 2 over 2, square root of 2 over 2. This is going to be the same distance, but in this direction, so this x-coordinate over here is negative. It's just a reflection across the y-axis of the point, and then the y-coordinate is going to be the same. Again, that's just a reflection across the y-axis. So again, so cosine theta, which is going to be cosine 3 pi over 4 is going to be the x-coordinate here minus square root of 2 over 2. Okay. Sine of 3/4 pi is the same y-coordinate as this, so it's going to be y, and that's going to be positive square root of 3 over 2. Now the tangent is going to be y over x. We know that's absolute value going to be 1, but there's a minus sign. So this is going to be minus 1. Okay. So what I'm going to do is I'm going to make a table, and we're going to keep these values in the table. So here's my theta. It's going to be on the, and here's theta is going to be over here, and then put the ratios here, just like before. And we have several angles, so I'm going to write them here. This is our reference. This is what we know. This is the really important one, square root of 2 over 2, square root of 2 over 2, and 1. And then we wanted to find 3 pi over 4, 5 pi over 4, 7 pi over 4. And then I had 2 more, and let me just check back to see which they were. We had 25 pi over 4, and we had minus 13 pi over 4. So we saw that the cosine was this negative. This was in quadrant 2. So we saw that that was negative. We saw that this y-coordinate was positive because it was in quadrant 2, and the tangent is minus 1. Okay, so we're going to use that same method. So we'll see how many I can do on this page. In fact, if you think you got it, hit pause and see if you can figure this out. I'm going to go through them all in a second. So I'll pause for a second, hit pause, try to do them, and come back. Okay, so I'm going to do the next theta is equal to 5 pi over 4, and that's going to be 5 pi over 4s. So this was pi over 4. This was 5 pi over 4. I'm sorry, this was 3 pi over 4. You'll see why I'm writing that. We saw that this was square root of 2 over 2, square root of 2 over 2. This was minus square root of 2 over 2, square root of 2 over 2. So we're going to go now 5 pi's. That's going to be 5 pi over 4 is 1, 2, 3, 4, 5. Notice same x-coordinate. So this is going to have the same x as here, but the opposite y. So this point here is going to be still minus square root of 2 over 2. The y-coordinate is going to be negative square root of 2 over 2, because as we noticed, y is negative in this quadrant. So this is going to be my angle 5 pi over 4. 5 of those, and then so then this is cosine. That's going to be, again, minus square root of 2 over 2. The sine of 5 pi over 4 minus square root of 2 over 2. And the tangent, again, is y over x. That's going to be 1 because we got 2 minus signs. So now I have this. I have minus square root of 2 over 2, minus square root of 2 over 2, and plus 1. Now the next angle is 7/4 pi. That's going to be 7. So I'll do it on a different piece of paper, but it's going to be 1, 2, 3, 4, 5, 6, 7. So that angle is going to be here. And notice it's going to be the same distance here. So think about that, and I'm going to redraw it. I'm going to keep the chart. We'll be coming back to it, but I'm going to just keep the chart itself and not. I think that picture is confusing. So again, now we want to do pi is equal to 7/4 pi, and we're going to use pi over 4 as our reference. So here's pi over 4. Seven pi over 4 is going to be 7 of these. Sorry. One, two, three, four, five, six, 7. Here's our angle. That's going to be theta equals 7 pi over 4. And the x-coordinates are going to be the same. And the y-coordinate is going to be negative because it's below the x-axis. So again, we get it again. Cos 7/4 pi is going to be equal to x, square root of 2 over 2. The sine of 7/4 pi, that's y. That's this y-coordinate minus square root of 2 over 2. And the tangent? Again, since x and y are more or less equal, one's negative, one's positive, it's going to be minus 1. Okay, so I'll go back to my chart. So I'm going to get, we said the cosine at 7/4 was equal to pi over 2. The cosine is negative, I'm sorry, the sine is negative, and the tangent's negative. So we got 2 more to do. So again, these are the key ideas here, and I'm just going to put everything on one piece of paper just so you know it. Okay, so again, this angle was 3/4 pi. This angle over here was 5/4 pi to here, and then this angle over here was 7/4 pi. I'm going to cross that out so it looks a little confusing to me. Okay, so let's do 25 pi over 4. Now it's 25 around. So you could count 25, but you could also realize that there's 8 pi over 4s in a circle. So there's going to be 8 pi over 4. That's go around again, 16 pi over 4. Go around one more time. That's 24 pi over 4. So 25 over 4 is going to be just one more pi over 4. I'm going to go draw that. So I'll draw the whole unit circle. And our theta is 25 pi over 4. Now what I have to remember is that theta equals 2 pi, which is 1 trip around the circle, is going to be 8 pi over 4s. 8 over 4 is 2. Okay? So that means if I go 2 times around the circle, so this much here is going to be 2 pi or 8/4 pi. If I go around twice, I'm going to go another 8 pi. 1, 2, 3, 4, 5, 6, 7, 8. So I'm here, and that's going to be 16 pi over 4. Go around another time. So I'm going to it's going to be 6 pi. 3 trips around the circle. That's going to be 24 pi over 4. So notice this is 1 more pi over 4 than, so 25 pi over 4 minus 24 pi over 4 is 1 pi over 4. So this angle, 2 trips around, 3 trips around to here, theta equals 25 pi over 4. That's going to have the same x and y, same trig ratios as theta equals pi over 4. Okay, so this is going to be equal to square root of 2 over 2 from what we saw before, square root of 2 over 2 here. Okay, so again, cosine 25/4 pi. That's the same as cosine of pi over 4, which from our chart is square root of 2 over 2. Same thing for the sine. And again, we saw from the chart the sine of pi over 4 is square root of 2 over 2. And one more, we have the tangent of 25/4 pi. That's going to be the same as the tangent of pi over 4. And if you go look on the chart, you're going to see that's equal to 1. So again, we're here. This is going to be the same as that. Okay, now we do minus 13 pi over 4. That's the last one we'll do. And we'll just have to see where we are. We're going to go around and see where we're going to end up. But 13 pi over 4, remember that one trip is 8 pi over 4. 13 is going to be 5 more, so we're going to go around the opposite direction. That's going to be 8 pi, 10 pi, 12 pi, 13 pi. So we're going to end up right there. And that should be the same as if we went this direction in terms of the x and y coordinates. But I'll talk about that in a second. So here's the last one. We want to do the theta is going to be equal to minus 13 pi over 4. And you want to find the cosine of minus 13 pi over 4. And I'm going to go back and look at the chart. It's going to be the same as one of these angles here. We don't know which one yet. So let's see. Okay. So the idea is how many trips around the circle is minus 13/4 pi. Well, we know it. We know that it's going to be, and we're going to be going in this direction, so opposite, and it's going to be going in clockwise direction. So how many trips around? And we know that minus 2 pi is going to be the same as minus 8 over 4 pi. And so we're going to go 5 more to get to 13. So 5 more pi over 4s than 1 trip. Okay, so let's do that. So minus 13, we're going to go this direction once. That's 8 pi over 4s, 10, 12, and 1 more. So that's where we're going to go. This is going to be theta equals minus 25/4. Theta is minus 13. I was confusing with the one we did before. Minus 13 pi over 4. Okay, well that's going to be the same as the same x and y as if we went this way, which was 3/4 pi, or 135 degrees. So we're going to, if we went 1, 2, 3 this way, 3/4 pi, we get the same x and y. So at 3/4 pi, we saw, go back to the chart that we did. It's kind of messed up because it's been used a lot. But here we saw minus square root of 2 over 2 plus square root of 2 over 2. So cosine is going to be, it's going to be the same as 3/4 pi minus square root of 2 over 2. Sine, square root of 2 over 2. Tangent was minus 1. X over y, but a minus sign. So again, we'll go finish the chart. We said this was the same as 3/4 pi minus square root of 2 over 2 plus square root of 2 over 2 minus 1. Okay, so that's it. So we're going to do this in the practice with other angles, and the key is going to be to recognize, let's go back and look at that chart. We're going to use this chart, and all the angles I'm going to give you in the next video are going to be some multiple of these angles. So we're going to use these angles to find out what the trig ratio is, and it's going to be very similar to what we did here. Okay, thank you.